Alright, this is lesson 4.5, and we're going to talk about how to find determinants and inverses of matrices. Now these are some things we're going to show you how to do them on the calculator eventually, but you're going to also need to be able to do them without a calculator, because remember that part of your test will be without a calculator. Now a real number called a determinant is associated with every square matrix. So remember, the matrix has to be a square matrix, 2 by 2, 3 by 3, 4 by 4. Now we are only going to learn to do by hand, without a calculator, 2 by 2 matrices. In college algebra, I require that students learn 3 by 3, but the larger the dimensions, the more difficult it is to be able to find the determinants. So, first of all, that's one thing you have to remember, is that we need a square matrix, okay, when we're talking about finding determinants. And we typically use vertical bars instead of brackets when we're finding the value of the determinant. So those are some things you need to kind of highlight and remember on your notes. Now you notice here that we have here a 2 by 2 matrix, and when we wanted the determinant of A, you would write it with almost looks like absolute value marks, and but you put the elements in the matrix in the same position. A is in the upper left, if you notice, B is in the upper right, C and D. Now the way you evaluate a matrix is that you evaluate it by multiplying on the diagonals and then subtracting the other diagonal. So I'm going to use a little highlighter here. There's A, and I need to make it a little more transparent. Okay, and we're going to, let's see if I can make that a little more transparent than I did. Yeah, it's not wanting to. Anyway. Okay, so we're going to change this to different color and see how to do. Okay, now we have D. So A times D, you multiply those, and then we multiply, then it's minus, the sign is always minus between them. Okay? And so after that, so it's A times D minus B, okay, B times C. So let's get a different color, maybe go more blue. Okay. Okay, times C. And so if that helps you to see how you do the diagonals to get the multiplication, then keep that in mind. It's always, sometimes it's helpful to have that. Alright, so the yellow one corresponded, if we went back and highlighted like we had before, okay, the yellow one corresponded, if I can find yellow here on my, okay, to this one right here. Okay, then we had pink. If you want to highlight them in the same spot, I'm having trouble getting the same color exactly highlighter, but then you have pink here, and then we had green, and I'm not going to do this for every one of them, but it might help a little. So then we have green on this one and blue on the last one. So if you want to highlight, some of you are getting to where you like to highlight, you're understanding that that helps you. Okay, then the blue would be here. Alright, so in practice though, sometimes I like to think of an arrow minus this arrow. Okay, So we have 3 times 2 minus 5, okay, times 1. 3 times 2 minus 5 times 1, which is then 6 minus 5, or 1. So the value of the determinant is 1. Okay, so if I was going to go over here and write the way you would write that answer, the determinant of A equals 1. Right? Just multiply the first diagonal, then subtract the second diagonal. Now this one I'm not going to do with a highlighter. That's going to take a little more time than I want. So here we have -1 times -2, okay, then minus -3 times 4, okay, so that's going to be -1 times 2, -2 is +2, minus a -12, so that's plus 12, and so the determinant of number 2 of, we'll call this one B, but it's really number 2, is equal to 14. Okay? So the determinant of B is equal to 14. Now I have a little stray mark there. Let me get rid of that. So, for inverses, it's a little different story. Determinants are fairly straightforward, not too much trouble. Inverses are a little difference. Let's multiply these. And remember, we always multiply row by column. Okay? So, to find this matrix, okay, to find this matrix, you'd have 1 times 11, or 11, plus -5 times 2, so that's going to be -10. That's going to be the first part of your answer matrix. Then we have 1 times 5 over here, that's 5, plus 1 times 1, which is 1. Okay, -2 times 11 is -22, plus 11 times 2 is 22. Okay, and on this, and this should have been -5, so let me go back. That's a mistake. Okay, on this, in this spot on the upper right, you had 1 times 5 is 5, plus -5 times 1 would be -5. So I made a mistake on that one. On the bottom, you would have -2 times 11, so that's -2 times 5 is -10, and -11 times 1 is 11. I'm confusing myself, so I know I'm confusing you. Okay, so now let's write that as our final answer matrix, and we have 1, 0, 0, 1. All right, so that is important. That's an important type of matrix to be able to recognize. When the products of two square matrices is the identity matrix, and that's what that is that you're going to call this. That's your identity matrix. This matrix here, not, erase. Okay, the matrix here that looks like this is called the identity matrix. Ones are on the diagonals and everything else is 0. So a 3 by 3 identity matrix would look like this. Okay, a 3 by 3 identity matrix would look like that, and that's not a very good. Let me get rid of that and try to do a different one. Okay, start here maybe. There we go. That's a 3 by 3 identity matrix. Ones are on the diagonals, everything else is 0. And so that's important information to be able to get when you're trying to find inverse matrices. So the symbol for an inverse is right here, A, -1. So this is your symbol right here for the inverse matrix at A to -1, and that's your symbol for the inverse matrix. Okay, and it's red, just like it says here, the inverse of matrix A. And you know, again, you know you have inverse matrices when you multiply them together and you get an identity matrix. All right, so now we're going to try to find the inverse of a 2 by 2 matrix. And that's harder to do by hand, but it's not impossible. This is the basic formula that you're going to need to memorize, and you just need to memorize it. There's not another way to do it. Right there, you need to memorize that formula. And that is the inverse of matrix A. You do 1 over the determinant of A, which we learned how to do at the beginning of this lesson. And then notice what happened. Here is our original matrix. Okay, and we had, let's see if I can remember what was in what spot. We had yellow. Okay, we had yellow, and I'm having trouble getting yellow for some reason. Okay. There we go. Okay, we had yellow in this first spot right here. All right, now in our inverse matrix, when we multiply, it's down in the bottom right instead of in the upper left. And our B, what was B, was green. Okay, it was green. Where is it now? It's in the same spot, but it's an opposite sign. Okay, it's in the same spot, but it's an opposite sign. And I believe D was pink, and if I'm not exactly the same, I apologize, but you know, you can figure it out hopefully. Okay, D was kind of pinky. Okay, so D is here. Originally it was in the lower right. So A and D swap places. C and B, C which was blue. Okay, C which was blue, and B changed signs. So you have to, that's what you need to remember when you have these, when you try to set up to find the inverse of a matrix. You have to do some changing around within the matrix itself. If determinant of A equals 0, okay, right here, if the determinant of A equals 0, then A has no inverse. And the reason for that is, if A was 0, this 1 over determinant of A here, right here, that 1 over the determinant of A would be 1 over 0, and you can't do that. So if the determinant of A turns out to be 0, there is no inverse. Okay. Now, find the inverse of each matrix. Let's move up and find this. Remember, you have to find the determinant first. That's the first thing you're going to have to do. So first of all, we need to find the determinant of, we'll just say 5, determinant of 5, determinant of matrix 5. Okay, we're going to call this matrix 5. Now we're going to do that by -9 times -3 minus 6 times 5, which is positive 27 minus 30, or -3. So, going back to our formula, 1 over the determinant of A, that's going to make this 1 over negative 3 because the determinant of A was 3. Now we need to shift things around within our matrix. Swap A and D, so this is now negative 3 and negative 9. Change the signs on C and B. So it's going to be negative 6 and negative 5. Okay? Now we just do our multiplication. And this is multiplying by a scalar, so it's not too difficult. 1/3 times negative 3 times negative 1/3 is positive 1. Negative 6 times negative 1/3 is positive 2. Negative 5 divided by negative 3 is positive 5/3. And negative 9 divided by negative 3 is positive 3. Alright, so that would be the inverse of that matrix. Let's do the same thing for 6 and 7. Okay? First we find the determinant. So we're going to find the determinant of matrix number 6. Usually you give a matrix a letter. I didn't give these letters. I'm just using the problem number. Okay, we want the inverse of that matrix. That's what that looks like negative 1 as an exponent means. The determinant then is 6 times 8, which is 48, minus 16 times 3 is 48. So 48 minus 48 means our determinant is 0. Okay, so that would set up as 1 over 0. Okay. We'd swap A and D, change the signs on B and C. So, I have forgotten my rule, haven't I? And hopefully you didn't. Hopefully you're sitting there saying, Miss Beck, Miss Beck, Miss Beck, oh my gosh, don't you remember you can't do it if the determinant is 0. You cannot, this has no inverse because that is not, you can't evaluate 1 over 0. So the answer here is not possible. Okay? Not possible. Can't do it. Okay, so be on the lookout for that sort of thing to happen. Now let's look at number 7. Again, we have to find the determinant first, so we're going to call that matrix 7. The determinant of matrix 7 will be 1 times 0, or 0, minus 3 times negative 2 is negative 6, and that's positive 6. A piece of that can be 0, but the overall value is still 6. So 1 over determinant is 1/6. Now we need to set up our matrix to multiply by. Swap the first diagonal, so we have 0 and 1. Change signs on the other diagonal, so that's negative 3 and positive 2. Now you're just going to multiply by that scalar 1/6. Okay. Okay, so I'm going to try to move this again without making a mark. All right, now 1/6 times 0, anything times 0 is 0. Okay. Then we have 1/6 times negative 3. Negative 3 over 6 is 1/2. So it's negative 1/2. Then 2/6 will reduce to be 1/3. And 1/6 will not reduce, so that's just 1/6. And I want you to leave these as fractions. Don't make them decimals. Don't evaluate them in the calculator to make them decimals. Leave these as fractions. Okay? All right, that is the end of 4-5.